Welcome back. Today, guys, on Chem Talks, we are going to start looking at gases, but we're going to look at them quantitatively. That means we're going to put numbers to them. We're going to start doing calculations. So it's real important as we go through this video today that you are getting down all these examples on how to manipulate these problems. That way you can be successful. So let's go ahead and get started. Basically what we see, the gas laws are simply mathematical representation of the relationships among the different factors of temperature, pressure, and volume in a given quantity of gas. And there's three basic laws that we're going to work on today, and then two more in a later episode. But the three today are going to be Boyle's law, Charles' law, and the Guy-Lascas law. So let's go ahead and get started on these, and we'll look at Boyle's law first. Boyle's law shows us or demonstrates the relationship between pressure and volume. And basically what Boyle's law says is this, is that the pressure and volume of a sample gas at a constant temperature are inversely proportional to each other. Remember what inversely means? Inverse means that as one increases, the other is going to decrease. So if we increase pressure, we decrease volume. If we decrease pressure, we increase the volume. They move in opposite directions, kind of like a teeter-totter if you think about that. They go in opposite directions. The equation for it is this, that P1V1 is equal to P2V2, where P is your pressure, V is your volume. Okay, and what we'll end up doing is we'll give you three of these factors, and you need to rearrange the formula to figure out the fourth one. So let's try a couple examples here. First example, it says 75 milliliters of gas is collected at 680 millimeters of mercury. What's the volume at STP? Well, first of all, think back STP, standard temperature and pressure. Okay, so we're going to have to know those values. So if we set this up, we're going to use P1V1, and up here is P1, pressure 1, our volume 1 is 75. Okay, and it wants to find our volume, so it wants to find V2. So the first thing I would do is rearrange this equation for V2. All I did was divide this side, each side by P2, and we get V2 by itself. So we know that P1 is 680, V1 is 75 milliliters, P2 is our pressure. Well, what is our standard pressure? It's 1 atmosphere or 760 millimeters of mercury. So when I multiply this through, I get an answer of 67.11 milliliters. Pretty simple. Only trick with this, you got to remember what STP is. Alright, problem number 2 here. It says 55 milliliters of a gas is collected at STP again. The pressure is changed so that the new volume, the volume 2, is 250 milliliters. What's the pressure in atmosphere? So let's look at what we have. Once again, P1V1, we're looking for pressure, so we're looking at P2. So to isolate this, I divide each side by V2, and that gives me this. Now let's look what I have. Here's volume 1. Pressure 1, once again, is STP, so it's 760 millimeters of mercury. And then V2 is going to be volume. Now, I'm going to change that 760. In my head, I also know it's 1 atmosphere. Why am I going to use atmosphere rather than millimeters of mercury? Because my final answer wants to be an atmosphere. I can do it and then convert it later, but it's easier if I just start in with atmosphere. So I'm going to take 55 times 1 atmosphere, divide it by my new volume, 250, which gives me 0.22 atmospheres for our answer. Let's try one more problem here. Okay, it says a flask containing 155 milliliters of hydrogen gas was collected at a pressure of 22.5 kilopascals. What pressure would be required for the volume of the new gas to be 90 milliliters? Once your answer's in atmosphere. So at the end, we're going to have to do some converting. So what am I looking for? I'm looking for the pressure, so P2. So once again, I'm going to rearrange. So P2 is P1V1 over V2. And I know my pressure 1 is 22.5 kilopascals. My volume is 155. And then my V2 is 90. So I set the problem up like this. And I get 38.75. That should be 38.75 kilopascals. Now what I have to do is I have to convert kilopascals to atmospheres. You may need to look back at your notes from the last podcast to see how we did the conversion. But I know that 1 atmosphere is equal to 101.325 kilopascals. Okay, my kilopascals will cancel out. I'm left with atmosphere. So I have an answer of 0.3 atmospheres. Pretty simple, guys. You just got to be able to rearrange this formula here. Okay, let's go on to the second law. Our second law is Charles' law, and Charles' law gives us a relationship between temperature and volume. It says that at a constant pressure, keeping constant pressure, the volume is directly proportional to the absolute temperature. Absolute temperature means it's in degrees Kelvin. This is why we talked about earlier that we need to make sure our temperatures are in Kelvin. And it's directly proportional. That means as one increases, the other increases. As one decreases, the other decreases. Our equation for Charles' law is this. V1 divided by T1 is equal to V2 divided by T2. So make sure you get that copied down. Let's try a couple problems here. First one says that a 14.9 millimeter volume of gas is measured at 25 degrees Celsius. If the pressure remains unchanged, what will be the volume in milliliters of gas at 40 centimeters? So we're looking for our V2, okay? But the only trick to this is they give you our temperatures in Celsius. So we have to convert from Celsius to Kelvin. Remember, to do that, we add 273. Okay, so we use this equation. We're looking for V2. So when I rearrange, I can set it up like this. Remember, so for 25 degrees Celsius is 298 Kelvin, 40 degrees Celsius is 313 Kelvin. Now to get V2 by itself, all I have to do is take this side and multiply it by 313. So it looks something like this, and I come up with 15.65. So I increased the temperature, I increased the volume. Let's try another problem here. It says the gas in a 1 liter bottle at 25 degrees Celsius can be put into a 1 quart, which is 0.946 liter bottle, at the same pressure if the temperature is reduced. So what is this? What's temperature in Celsius required to reduce this? So they're going to ask at the end, we want temperature, but we want it in Celsius. So we're going to have to convert from from Celsius to Kelvin, and then back from Kelvin to Celsius for our final answer. So we're using this one again, equation. So let's set it up. We got, notice, 1 liter bottle, okay, is what we're going to, 1 liter bottle here at 298, which is 25 degrees Celsius. We're going to reduce the volume to 0.946. So what do you think the temperature is going to have to do? If we're reducing volume, we got to reduce the temperature. So in order to solve for T2, well, we have to rearrange it. So we have to rearrange the equation for T2. T2 looks something like this. V2 times T1 divided by V1. Okay, when we put it out, it looks like this. We get an answer of 281.91 kelvins. Now remember, it doesn't want kelvins, it wants Celsius. So to go from Kelvin to Celsius, we simply subtract 273 and end up with 8.91 degrees Celsius. Pretty simple there. A little more complex as far as rearranging this equation than it was with Boyle's law. Last problem for Charles. If we have 60 milliliters of nitrogen gas at 22 degrees Celsius, what change in temperature must occur to have nitrogen gas occupy a volume of 70? Okay, so we're kind of first thing we're going to do is find T2. So rearrange here. Okay, once again, T2 is going to be V2 T1 over V1. So it looks something like this, and we get a temperature of 344.17 degrees Kelvin. Okay, but it wants to know what we get it in 71.17 degrees Celsius here. Okay, but it wants to know the temperature change, right? So to do the temperature change, we take our initial temperature and subtract that from our final. So 71.17 minus 22 degrees Celsius gives us a temperature change of 49.17 degrees Celsius. You need to be careful what they're asking for. They weren't asking for the final temperature, they're asking for how much the temperature changed. So be aware of that little trick there. Our final law today is the Guy-Lascas law. And Guy-Lascas is a relationship between pressure and temperature where we're keeping the volume constant. It says, for a given amount of gas held at a constant volume, the pressure is directly proportional to the absolute temperature. So once again, we're doing temperature in Kelvin, and it's going to be a direct relationship. So one increases, the other increases. One decreases, the other decreases. The formula for it is similar to Charles' law, but instead of dealing with volume, we're dealing with pressure. So P1 over T1 equals P2 over T2. So let's try a problem here. It says 10 liters of a gas is found to exert 97 kilopascals at 25 degrees Celsius. What would be the required temperature in Celsius to change the pressure to standard pressure. Okay, well, we know standard pressure is 1 atmosphere, so we got to figure that in our mind what that is in kilopascals. So let's set up our equation here. Well, we know P1 here, okay, T1, okay, we're looking for T2, and then we got to find P2. Okay, so we're in kilopascals, so standard temperature and pressure. Standard pressure is 101.33 kilopascals. Once again, rearrange and solve for T2, and you get 311.3 Kelvin. Now, once again, it doesn't want Kelvin, it wants degrees Celsius, so we subtract 273 from this and end up with 38.3 degrees Celsius. All right, here's what I want you to do. See if you can do this one on your own. Pause the video, copy it down, work it, and then come back and try it. All right, did you do it? You didn't cheat, hopefully. Hopefully you hit pause and work this, because it's not going to do you any good to cheat. So if you didn't, pause it, work it, do it now. Okay, 5 liters of gas collected at 22 degrees Celsius and 745 millimeters of mercury. When the temperature is changed to standard temperature, what is the new pressure? So we're looking for P2. Okay, so we got to rearrange for P2, just multiply the left side by T2. There, and so you get 745 millimeters of mercury over 295. Okay, how do we get that? Well, we took 22 Celsius plus 273. Okay, and then standard temperature pressure, or standard temperature in this case, is 273 kelvins. So when we rearrange and multiply, we end up with a pressure of 689.44 millimeters of mercury. Pretty straightforward on this one. All right, today, guys, we put quantity or math problems to our gas laws, things that we've talked about. You need to know these 3 equations. You need to be able to know how to rearrange them, how to solve for any given variable in there. If you're having problems rearranging those, please come and see me before class. I will help you do this. It's not too hard. It's just basic algebra. But if you're getting stuck, let me know. A couple things to remember. What are our standard temperature and pressure volumes? You need to know those. And remember, all temperature is done in kelvins, not Celsius. So you need to know how to convert from one to the other. All right, guys, until I see you in class, take care.